what is this question? Look at all those 3's and n's and 2's, and there's a fraction, but we'll be fine. So we need to simplify this. That's great, because it doesn't look that simple right now. So you'll notice there's, 3 3's, and then there's a 9 as well. So I'm thinking if we can express this 9 as a 3, we'll then be able to simplify using power rules. So first step is just a side note. Let's keep it a bit simpler first. So 9 to the power of n, well, we can write 9 as 3 squared, right? So 3 squared is 9, all to the power of n. Powers of powers, multiply. So 9 to the power of n is the same as 3 to the power of 2n. All right, so we can use that idea to express this term to have a base of 3. So let's do that first. So we have 3 to the 2n minus 1 plus 3 to the 2n plus 1 all over 3 to the 2n minus, so instead of 9, we'll put 3 squared, just like before, but this time the power is n minus 2. So now we can then expand that power out. So let's do that next. Everything else stays the same. So 3 to the power of 2 times n, and 2 times minus 2, minus 4. So this is looking a little better. You'll notice in the numerator and denominator, it's plus and minus. If it was multiplies, there would be factors that we could then more easily cancel out. So we should factorize it, right? So pull out a common factor in the numerator and the denominator. Hopefully they'll cancel, right? And we can then make it more simple, right? Simplify it. So in all of these terms, I see a 3 to the power of 2n. So 3 to the power of 2n is a common factor in the numerator. And then what do we need to multiply that by to get 3 to the power of 2n minus 1? So remember, when we multiply exponents, we add the powers. So here, 3 to the power of 2n times 3 to the power of negative 1, we'll just do a side note, multiplied by 3 to the negative 1 is 3 to the power of 2n minus 1, right? We add the powers with the same base. So for this one, we'd get 3 to the power of 2n minus 1. Similarly, this term would be 3 to the power of 1, right? To expand it to get that term. So we've factorized the numerator. We can do the same with the denominator. 3 to the 2n is a common factor. Well, 3 to the power of 2n times what equals 3 to the power of 2n? 1. All right, or if you want to be extra fancy, I guess you could actually do, 3 to the power of 0, because that is also equal to 1. But we're not feeling fancy today. And then minus 3 to the power of minus 4. All right, so we factorize that. Now notice the 3 to the power of 2n's actually cancel out, which is great. And then we're left with all these numbers, which are just numbers, right? So 3 to the power of negative 1 is actually 1 over 3, which is a third, plus 3, all divided by 1 minus 1 over 3 to the power of 4. So I just expressed that negative power as a positive power number. But before going down this rabbit hole, how's about we just don't? And when we get to here, we can use our calculator to compute the value, because it is asking us to simplify. So we have 3 hat, so to the power of -1, plus 3 to the power of 1, which is just 3, all divided by bracket 1 minus 3 to the power of -4, bracket, execute, which is 3.375, which as a fraction, so I just hit this button called F arrow D, it's above 8, which is 27/8. And we're done. That is a lot simpler than what we started with.